Hello, this is Professor Kim Nelson with the Jewelry Design Department at the Fashion Institute of Technology, doing another tutorial in a series of tutorials for modeling jewelry in Rhino. Continuing with the topic of C-planes, I'm going to do an exercise here, or a demonstration, on how to use some of the basic C-plane management commands in Rhino. To facilitate this example, I'm going to make a prong for a round stone with that prong in the 45-degree angle. Okay, now if these prongs were set on a cruciform pattern, like so, then I wouldn't have any reason to rotate the prongs, to rotate a C-plane or create any custom C-planes, or at least not many, in order to execute the prong model. Alright? Because I have C-planes that actually line up with these orientations. I have a top, I have a front, I have a right. So I wouldn't need these surfaces representing those C-planes. I wouldn't need to create any C-planes for this. And truthfully, myself and most other folks would model a prong for a round stone using these standard C-planes and then just rotate that prong 45 degrees. So, I guess I'm trying to be as honest as I can. In reality, if I were modeling these prongs, I would model them in regular C-plane orientation and rotate them. But that won't work well for other stone shapes. For an emerald cut, or a marquee, or a pear shape on an oval, any of those, the angle of the prong has to be specific to stone, and it's very hard. I shouldn't even say it's very hard. It's not very successful generally to try and model the prong using a standard C-plane configuration, and then to try and then orient that prong to get it where you want it. It's possible, but you're going to make decisions that perhaps would not be valid. So I would always recommend to model those prongs in situ at the angle that they need to be. So we're going to pretend that this is one of those situations. I am going to go ahead and model a prong at a 45-degree angle. Notice that I do not have any C-planes that will meet my needs. They do not line up with these surfaces that depict where my C-planes would need to be. Okay. So, the first thing I'm going to do is create a top view C-plane that is rotated 45 degrees. That 45-degree angle, I didn't just throw out of the makeup and toss out from thin air. As I've been saying all along, that is the angle this prong is going to be at. So first thing I want to do is rotate my top C-plane so that it's oriented properly for a 45-degree angle part. Command for that is right here, rotate C-plane. Now when you see the command line here, it asks you for a start of rotation axis. Right now is set to 0, 0, 0, which is fine. So I'm going to hit hit enter and accept that default. Now the other thing, turn off grid snap for a minute. The other thing that it's asking me is X, Y, Z. Okay. Now that's asking me which axis I want to rotate on. Okay. So do I want to rotate on Z or Y or X? That's looking, whenever you get a question like this, as far as rotation axis, what they're asking you, the program is asking you, is to visualize that you are looking down that axis as if it were a telescope, as if it were a lens at the bottom, and that lens is the plane you're trying to rotate. So in this case, we want to rotate the top C-plane, so we want to look down the Z-axis. Remember, the green line We talked about this in previous videos. The green line represents the x-axis. The red line represents the, that's y, red is x. Z, you can see it in the icon over here, is straight up in the air. And that's the one we want to look down. We want to look down this axis at the top seaplane. So select Z. Now it's going to, like most rotation commands in Rhino, it's going to ask for 2 points. A first and a second reference point, which I always like to refer to as where it is now and where you want it to go. So, turning back on the grid snap. Actually, I can leave it off a minute. I'll just hold Shift key. Pull out this direction and click anywhere. And Rhino uses that as a reference for where the seaplane is oriented right now. And you can see how those axis lines are moving now. I want them to go to 45, so I could type in 45, or I can just use the grid snap and catch on to this first diagonal corner of the grid. And I now have rotated that top seaplane. You can see that it does line up with my prongs. I want to save this seaplane, so pop out my menu from my viewport title bar and going to come to Set Seaplane, and at the bottom of the list select Named Seaplanes. And I will save this, clicking on the Save As icon, and I'll call it 45 top. So that seaplane is now available to us in our list of seaplanes. And I will want a vertical seaplane to accompany this, so I will come back over to this list of commands and select Set Seaplane Vertical. Seaplane origin is 0, 0, so I'll just accept it and hit Enter. And now it's asking me where I want to have this x-axis line. I'm going to keep it in the same position as it was on the top seaplane, like so. And now I have a vertical seaplane oriented along 45-degree angle. Going to save that. It's 45 front. So now I have these two seaplanes available to me. If I go back to my top seaplane and I X out that dialog box, I can get those back by using our classroom shortcuts and Enter. We'll recall the Name Seaplanes dialog, or you can just pull it from here. Set Seaplane, Name Seaplanes. If we double click on 45 top, we have that new 45 top seaplane, and if we double click on 45 front, we have the new 45 front seaplane. And this is the one we're going to start working in. You will notice that now we do have the seaplane oriented to this surface. I don't need to have another seaplane running perpendicular, but I could create one using the same techniques we've used. This bead, which I put in position, is to indicate the location and size of our prong, which is a 1mm prong. I'm going to put a point in the center of that for reference. Go ahead and group those together. I want to move this bead away from the stone to where it is barely biting into the girdle. Turn off grid snap so I have fluid movement. Hold down the Shift key so I have ortho. Please notice that the Shift key is now ortho based on the new seaplane, which is perfect for what we want to do. I just want it to bite in very slightly. That's plenty. That's fine. And our point remains. And the whole point of doing that was to be able to see where the prong is going to go and to have this center point so we can start drawing a curve for our prong wire. To draw that curve, I'm going to draw a line both sides from that point. I want it to flow, fairly a good taper. In commercial jewelry, they'll often have this come down to the center of the ring bore. I find that to be not a very attractive angle. I like to snug it in more. Something like that is fine. Make sure the end of your line drops well below the ring bore. Okay. Now, I dragged that in accidentally. I wanted to double check that. Yeah. Okay. That's where it should be. I'm going to now crop off the top of this prong wire 1/2 millimeter above the table. To do that, I'm going to grab my surface tool, grab my cut plane, end snap, and drag from any corner of the table. It really doesn't matter. Hold the shift key in either direction, left or right, pulling out to a nice straight horizontal, and click. And you will get that cut plane, which is now, of course, equal to the top of the stone. Move that up 1/2 millimeter and enter. Click for your starting point. Type in 0.5 to constrain your distance. Shift key to hold it straight up. And then trim. Going to hide this in case I want to pull it back later. And change the color of the wire. My favorite math for making a prong wire is 4-3, simply because it's a very simple curve and a very difficult curve to make ugly. It's too simple of math for many other purposes, but for this purpose it's fine. 4 and 3, 4 points, 3rd degree curve, delete input, yes. Turn on my control points, and then adjust my control points to get a nice arc to that curve. Now, the challenge is, in making that nice arc, I came away from where I want the center of that prong to go. I can rotate that back by just grabbing the end of the prong and rotating by eye until it passes through that point. But if I want precision, please notice the graphic that Rhino's creating here. Do you see the circle with the gap? This is a good hint to what Rhino's doing mathematically. It's creating a circle on the C-plane and then rotating this curve along that circle. If I want precise rotation, I'm going to escape out. If I want precise rotation, all I need to do is draw an actual circle from the end of the prong wire to the point I want it to go to. This just replicates what it is that Rhino is trying to do anyway. Now, for some reason, I'm not sure why, that left my C-plane. I'm going to redraw that. Always good to keep double checking. And I rotated that, and I could see that somehow that got rotated. I think it's because it snapped to one of these drawings under here. That's why I turned them off. Always good to keep your geometry minimal when you can. So I'll do that again. End, point. There we go. So, to rotate this, like any rotation command in Rhino, it's going to ask me for an origin. That's the part of geometry you don't want to move, or the location in your model that you don't want to change. That's where your origin will be. Then it's going to ask for 2 points. A reference for exactly what the geometry is doing now, and a second pig point for where you want it to go. You'll hear that a lot in my tutorials. So, transform, rotate, or center of rotation or origin. We don't want to copy, by the way. Copy equals no. End. To show where this is at now, we're going to use some precision and get an intersect snap and hit where the curve intersects the circle that we drew for reference. That indicates where the geometry is now. Rhino understands that. We come over and grab the point, and we now have accurate rotation. Okay, I usually will leave this in here until I'm through. I know I've got what I want. Say if I came back in here and decided I wanted to play with this even further, for whatever reason, and I ended up knocking this off. If I wanted that precision to be maintained, rotate 2D, end for my center of rotation, intersect where it meets the circle reference, and point snap to put it where I want it. I can throw that away now. So we now have a prong wire. Okay. I can check and see if the height changed. It won't really matter much. It has. So I'll trim that wire. And I won't need that again, so I can delete it. So, sorry about all the scary geometry that popped up there. I've been using this file for a number of things. So there's a bunch of stuff on the hidden layers. Okay. So the next step in making my prong is to create a maquette. My process for modeling is to almost always anyway, create a maquette of what I want out of very basic tools and then extrapolate advanced surfaces from those tools. So in this case, I will make a prong wire by using a pipe command. So solid pipe diameter, please, 1 millimeter at the top, and just enter again for 1 millimeter at the bottom. And that is a pretty good representation of a 1 millimeter wire. And you can see it is oriented appropriately to show that sphere inside. Lined up just right. Okay. So this is a nice maquette for a basic prong that's going to be straight. I want to taper my prong, however, so I'm going to actually use slightly different numbers. I'll keep it 1 millimeter at the top, but at the bottom I think I'll try 0.9. And I'll take a look at that and see what I think of that taper. I want to keep in mind where the ring bore is, because I'm going to lose all of this. That's not much of a taper. I'm going to taper it more. So start diameter I want to be 1, not 0.9. Remember, Rhino can start this from either end, so always double check your command line. I want 1. And at the bottom I want 0.85. Now that looks really severely tapered, but when you compare it with the ring bore, it's actually quite modest. I'll take it down to 0.8. 1 at the top, 0.8 at the bottom. Okay, so that's a nice visual in the maquette of how I want the taper from this view. But I'm going to do this as if it were a handmade setting, not for mass production, but a handmade, one-of-a-kind piece. And in that scenario, I actually want it to be tapered narrower from this view, but from the front, I want it to get wider as it comes down, to give the stone more support to reach in and grab the setting wires more effectively. Okay, so this is good. I'm going to turn that layer off, and I'm going to start this process again. Pipe at the top, I want it to be 1. At the bottom, I want it to be 1.2. I want to feel that spreads out fairly boldly. Want more. 1 at top, 1.4 at the bottom. Okay, now that's good. So what I have now is I have several pieces of guide geometry here. I have a maquette to show me how I want it tapered from the front, a reverse taper. I have a maquette showing it tapering in the opposite direction, or what you would normally think of as a tapered prong. And I have a bead showing me the prong location. This I can go ahead and send into storage. I won't be needing that again. And if I do, I know where to find it.